Alright, we're going to talk about nets today. A net is a diagram of the faces of a three-dimensional figure arranged in such a way that the diagram can be folded to form the three-dimensional figure. So if you're looking at, say, a prism always has a bunch of rectangles on the lateral faces, and then it has two parallel congruent bases. So when you look at the net, you should see each one of those shapes. I don't know how well this is going to work out on the video, but I'm going to try to show that to you here. Here is a triangular prism, and if I unfold it, I take all the faces and unfold it, then you can see the net for a triangular prism. It's got the two triangles, which are the two parallel congruent bases, and it's got the three rectangles that go around the sides. So that would be a net of a triangular prism. And see how it can fold up to create that triangular prism again. Alright, so example 1 says draw a net that would form a cube and one that would not. So a cube has 6 faces and they're all squares. The easiest way to draw a net that works when you have a prism of some sort, which a cube is a type of prism, is to put all the lateral faces in one nice neat row, and then the two bases you need to put one on either side. So I could put a square on the right side, and then I could put a square anywhere on the left side. It could be up here at the top, it could be down here at the bottom, doesn't really matter. And obviously my squares are not drawn perfectly, but this is an example of a net that would work to form a cube. Now we're supposed to form one that does not form a cube. So let's say I have that same row of square faces. 1, 2, 3, 4. And I can put that first one right here where it was again, that first base. If I put the other base on the same side, that is not going to work. Because when we try to fold this up, these will end up overlapping and laying on top of each other, and the other side will be empty. So it would be like a box where the top is not there. We would miss that. We'd be missing that face. So here's one that does not work. Alright, example 2. If the net below is folded along the dotted lines, what type of figure would be formed? Well, when you see a bunch of rectangles, your first thought should be that it's probably some type of prism, and then you look for what would be the two parallel congruent bases and find out what shape those are, because that's the type of prism it'll be. Well, here I see nothing but rectangles, so I know it's a prism, and then the two other pieces are also rectangles, so this is a rectangular prism. I don't know how well you're going to be able to see this, but I'm going to try to do this. Here is that same net, and if I fold this up, it wraps around, and here is the rectangular prism. Not sure how beneficial that was. Alright, example 3. Draw 2 different nets that will fold to the three-dimensional figure below. So let's look at what we're looking at here. This is a triangular prism. I see the rectangles going around on the bottom, on the left, and on the right. And then I have two parallel congruent faces that are going to be the bases. And they're triangles, so that's a triangular prism. Remember, I showed you an example of a triangular prism earlier when I unfolded that big yellow net. Now, just like I did earlier, anytime you have some type of prism, the easiest way is to put all the rectangles in a row, all the side or lateral faces in a row, and then put one base on either side. So you're going to have one triangle on this side and another triangle somewhere on this side. Okay, let's do the same thing. We're supposed to come up with 2 different nets that will fold to create that same triangular prism. So one thing I'm going to do differently now is just move where they are, but I still have to have one on each side. I can't put them both on the same side. And this one looks more like that triangular prism net that I showed you earlier, if you remember this one. Alright, example 4. Determine whether each net will form a pyramid when folded to make a solid. If yes, classify it. So if we were to fold these up and create a three-dimensional figure, would these make a pyramid? Remember, a pyramid only has one base, and it has a bunch of triangles for lateral faces. So here, this would need to be a square pyramid, or at least a rectangular pyramid. So you would need a triangle for each side of that base. So there should be 1, 2, 3, 4 triangles. I count 1, 2, 3, 4 triangles. And this would indeed fold up to create the pyramid. Thought I had that. Guess I don't have that over here. Oh, there it is. Here is that figure. And if I fold this square under to be the base, these come around, and there is my square pyramid. So this one does. We're going to call it a square pyramid. Alright, will this one work? The base is a hexagon. It has 6 sides. 1, 2, 3, 4, 5, 6. So I would need 6 triangles, one for each face. One for each side of that base, I'm sorry. 1, 2, 3, 4, 5. There's only 5 triangles. There's not enough triangles to get all the way around. So if I were to take that and fold it, you will see as it comes around there's an empty spot right there, because there's not enough triangles to get all the way around and complete that solid. So this one does not complete a pyramid. And the last one right here, this, notice there's nothing but triangles. So not only the lateral faces, but the base as well has to be a triangle. So if this works, this would be a triangular pyramid. And it does work, and I'll show you how it works. Hopefully y'all can see this okay. If I make this the base, these 3 will just fold up to come to that vertex at the top. So I just fold these up, and there is the triangular pyramid. Alright, let's look at example 5. Draw the solid that would be formed from the net below from 2 different perspectives. This one can be challenging. You got to be able to visualize as you were to fold this up which things would be on intersecting faces and how those pictures would get turned and what way they'd be facing when you're looking at one or the other. So let's try this out. Hopefully y'all can visualize this in your mind a little bit. Let's try one perspective. Let's say I have the solid dot here. What could go here and what could go here? Well, it just depends on which way you've got this thing turned. I'm going to put this here. If I have both of those there, what would go on the top? You see how this edge and this edge would come together. And so picture that. Now if this is upside down, it's what's going to be on top of it, what's going to be here. And that's going to end up being that star as we fold that over. And that might be hard for you to just see visually, in your mind, excuse me, mentally. One thing you might want to do is cut one of these out and fold it up so you can get a look at it. So here's that. If I fold this up, can you see what we're looking at right there? There's the black dot, the little crescent moon, and the star on top. So that's the visual we just got. So there's one perspective. Let's try a different perspective. Let's say I put that crescent moon here, and you could come up with a lot of different possible perspectives. These are just two of them. If I put that crescent moon thing up here, go in that direction, then what would I have? Notice it's facing this way, so I want to know what's going to go on that edge to see what's coming down here. Well, right there I got a blank space, so that's going to be blank. And then what's going to be over here? What comes on that, what borders that side at the bottom part of that? Well, that curves down here, and I see the sun right underneath that. So over here would be the sun. So there's just two of the many perspectives you could do from this figure. Alright, last one. Find the surface area of the triangular prism with the given net. Round answers to the nearest tenth. When you do surface area of any figure, you can really just find the area of each individual shape and add them all up. Or there are special formulas that we have to shorten that process, so you can do it either way. This is a triangular prism. I see a bunch of rectangles, so I know it's a prism of some sort. And then I have two triangles. Remember, prisms always have two bases. So we have a triangular prism here. So if you're looking at a formula chart for a formula for triangular prism, the formula for any kind of prism is pH plus 2b, where P is the perimeter of the base and big B is the area of the base. Now, the one thing that can be tricky about doing it this way is you have to be able to realize what is the height of the prism when it's not even made into a prism. So you would have to be able to see that 20 is going to be the height. That as this folds up, you're going to have that triangle on top and bottom, these rectangles going around the sides, 20 would be the height. Now to do this, to get the perimeter of the base, we would need to find this piece, because we don't have that right now. But it's a right triangle. We know two of the sides, so we can do Pythagorean theorem. If you remember your Pythagorean triples, you can jump straight to the answer without doing all the work. The hypotenuse is the side we're looking for. We don't know it yet, and the hypotenuse always goes in for C. 6 squared plus 8 squared is 100. And then we take the square root to get rid of the squared, and I'll find out that this side right here is 10. If you can think about how all these come together, or here, let's just do this. The perimeter of the base, remember the triangle is the base, we just have to add up 6 plus 8 plus 10. So the perimeter is 24. The height of the prism is 20. And then I need the area of the base, so I can put that in there as well. Well, the base is a triangle, so the formula for area of a triangle is 1/2 times base times height. And remember, base and height are always perpendicular to each other. So the 6 and 8 are forming that right angle. Those are the base and height. It doesn't really matter which one's which. So I'll do 1/2 times 6 times 8. Gives me 24 for that one as well. So I know that the area of the base is 24. So I'm typing in the calculator, 24 times 20 plus 2 times 24. And that gives me 528. And this was in centimeters, so area is always centimeters squared. So that was finding the surface area by using the surface area formula for a prism. I'd like to do it by just finding the individual shapes areas and add them all up, treating it like a composite figure as well though. So that was way number one to do it. Let's talk about the second way to do it. Okay, you just find the area of each individual shape, add them all up. Well, this one we already found the area of that, it's 24. I'm going to rewrite the stuff over here because if you were doing it this way, it wouldn't already be done for you. Now, there are two of those triangles, so I would take that area and multiply that by 2. So 24 times 2 is 48. So now I've got both of the triangles' areas taken care of. All I have to do is find the area of these three rectangles and add them in. Well, area for a rectangle is just length times width. So for this rectangle, we got 6 times 20 is 120. For this rectangle, think about how this would fold up. This right here is going to match up with this. So it's 8 times 20, which is 160. 8 times 20 is 160. And then this one, think about how this would fold. This is going to match up here. This is going to hit that third side of the triangle, which is 10. So you got 10 times 20, which is 200. So now I got the area of both triangles, and I got the area of all three rectangles. All I have to do is add all of those up. So 48 plus 120 plus 160 plus 200. And I get 528. So there are two different ways to come up with the same answer there.